You've connected to Cisco Unplugged. Hello, everyone, and welcome to episode 72 of Cisco Unplugged, your show for all things wireless. I'm Dan Klamert, your host here with Al Dumdei. How are you doing today, Al?
Hey, good. Getting ready for Thanksgiving, warming up the turkey, all
Yes.
that sort of stuff.
What kind of stuffing do you like?
Oh gosh. Uh the
Do you like
breaded
do you like
kind.
nuts? Do you like nuts in the stuffing
Oh,
or not?
absolutely. I
Yeah,
like
okay,
everything.
good. Okay.
Load it up.
That's that's good. That's good. All
Yeah.
right. Well, happy Thanksgiving, everyone, here early, and thanks for tuning in. This week, we're discussing some expert insights on Wi-Fi planning and troubleshooting with Hamina Wireless. And I'd like to welcome Jerry Olla from Hamina back to the show. Sorry,
Yeah. He's a
Hamina.
veteran. Yeah.
How are you doing today, Jerry?
Doing very well. Yeah, thanks for having me on, guys, and happy Thanksgiving.
Yeah, happy Thanksgiving. Good to see you again. Thanks for being here. Thanks for
Yeah,
taking
this is
time the day before.
this one's been on the schedule for a while, and I just think this is one of those like information pack sessions, right? So Jerry's gonna kind of go through this a little bit, but we've got integrations with Cisco. We're
Mhm.
gonna touch a little bit on about our planning for like cellular, because you may remember the previous episode that we had like a couple episodes ago around the P5G and that sort of stuff. So we're gonna tie that into this.
Yep.
We're going to talk a little bit about ultra wideband, which is revolutionary new technology for location-based services and that sort of stuff. So this is going to be pretty much an action-packed, if we can get through it all.
Yeah, hopefully.
Pretty action-packed
Yeah.
session here. So
Yeah.
Jerry's going to be a busy man.
Yeah. I just got a couple reminders here before we get going. We do already have a question, but in lieu of that, I'd like to remind some others that we do take questions via Slido. So you can see the Slido QR code there on the screen to join, or you can also click the link below the video streaming on our YouTube channel. And speaking of YouTube, we are streaming this live on YouTube, and our channel is youtube.com/at get unplugged. Please go out there, like and subscribe, and click the notifications bell so you will be notified when we do go live with great content like this. So, with that, go ahead, ask any questions you got during the show, and I guess let's get unplugged here and let's see what's new from Hamina.
Well, let's start with the first thing is, how do you pronounce it correctly, right?
That is always a good starting off question.
Yes.
So I think the easiest way is to break it up into three parts. Ha, me, na, and then you just say it fast and confident, and you're gonna be good.
Hamina. Yeah. Emphasis
Hamina,
on
you
the
got it.
H, I think.
I feel like I got it like
Right.
two out of the three times there on the intro.
You
No
missed the
worries.
confident part. Is the part you missed.
That's right.
Yeah, yeah, exactly. I'm working on it. I'm working on it. So
All
that's
good.
after a town in Finland, is
It
that?
is, yeah, yeah. So a little fun fact there is, yeah, Hamina was named after a small town. You could say UC, the CEO and founder, kind of put the
Mhm.
town on the map, if you will, in the sense of, yeah, I had not heard of the town of Hamina before working here at Hamina, but yeah, learned all about the town of Hamina. And then if you really want to dive deep, Google Hamina and walrus, and you'll know the insider info on the walrus connection with Hamina and why we have Easter eggs of walruses and things like that in the tool.
Well,
Well,
that was
Jerry,
actually the
that's
first
funny you
question.
mentioned that because
Yeah,
that's the
go
first
ahead.
question we have here from Herr Nelson. On first and most important question is, where is Jerry's walrus?
It is here. It is nearby, near and dear. Yes.
Oh, look
Thank
at
you, Herr Nelson,
that.
for that, Anders. Very much appreciate my walrus. I know I need to get it. There's only so many things I can display in the video here.
I'll ask what would be maybe his next question. Does he have a name?
So the Finnish pronunciation, which I'm not good with my Finnish, but I believe it would be morsu. Anders could probably correct me if I'm wrong there, but yeah, morsu is a walrus in Finnish.
Ah,
Nice. Nice. That's
very
awesome.
good.
All the things you learn on these unplugged episodes.
Yeah. Well, good.
That's
Well,
awesome.
let's start off maybe. I think you've recently. So we've always had some integration with
Yeah.
Hamina and Meraki, right?
Hmm.
But
Hmm.
there's some new news from you guys with Catalyst Center, correct?
Yeah. How about share my screen instead of just talking about it, and I can show you some of the integrations that we've got. So yeah, to your point, we've had
Yeah.
both on the import and the export side for quite a while now with being able to import information from things like Cisco Meraki, but now we've added things like Catalyst Center as well, where we can pull in information from there. And probably what's most exciting is really on the live integration side. So let me actually just do this. I'm going to start a new project here, and we're just going to show a quick demo here of this latest and greatest integration. So if I go to the live side, you can see we can tap into all these data sources from multiple vendors, but Meraki and Cisco specifically here. And what I want to particularly show off is this latest integration with the Catalyst Center side. So this is actually our first integration with something that's not just in the cloud, right? So this is where things get pretty interesting, where we can tap into information from a Catalyst Center deployment and be able to pull in all sorts of information. So I've already got this plugged in, but I'll go ahead and pull in like a site here, and let's take a look at one that'll have some live deployment. So this is a real live deployment. In addition to that, I'll also even pull in my orb integration here, as we do have some additional insights that we can pull in from now orb. So not only that's one of the things that's unique with Hamina is maybe you already have access to something like some of that information that's in Catalyst Center, but we also want to pull in some information from other data sources like some type of sensors that can also be overlaid into these heat maps. So in this case, I'm going to pull all that in, just created a brand new project. So Hamina knows nothing about this site other than what it's learning right now from Catalyst Center, from Orb. And now we have all sorts of information that we can use to troubleshoot. So one of the first things it did there, when we learned about the floor plan, we learned about the AP locations, learned all sorts of other details that we'll get into here. But one of the things that I think is really cool is what it didn't learn about were where the walls are, where the doors are, where the elevators are, things like that. Hamina actually interpreted all of that just by the floor plan that we learned about from Catalyst Center. So the floor plan lived in Catalyst Center. We pulled that in over the APIs, and now we can start using kind of the Hamina magic, if you will, to now start building very detailed heat maps based on those floor plans.
And
So
that,
you can see all the
Jerry,
different.
and you mentioned this, I think, once before. That could just be a JPEG, right? That
Yeah.
doesn't have to be a detailed CAD drawing or anything like that, right?
Absolutely. Yeah. So this is kind of working in the different side of it of this is already an existing deployment, but we could do the same thing on the design side of things too, right? To actually do the initial design. But since this is already deployed, maybe we want to start from this angle of, okay, where are gaps? Where are issues? Where are users having a poor user experience? And we can drill down all the way into that level as well. So if I go to like the live clients, I can actually see we do have some clients connected to the network right now. And notice this one here in particular even has a score associated with it. That's coming from that Orb integration. So if the clients themselves are running the Orb agent or Orb application, we can get some additional insights from what that user experiences from an actual user quality. It gives it a quality score of the connection. So not just how the Wi-Fi is performing, how's the internet performing at that site? We can take all that together and aggregate that down into a score. But if I take like this client, for example, this Chromecast, we can see, yeah, this client is experiencing some poor performance due to high retries. So we're seeing all that. And again, we're learning all this information in real time from this Catalyst Center deployment. So this is a live deployment with actual Wi-Fi clients connected, and this is how that client is being reported to us by the infrastructure, in this case by Catalyst Center. And this works the same whether you've got Meraki or any other cloud infrastructure that we can tap into and pull that rich data out of to help you with visualizing. And the cool part is this site's over in Europe, and I'm over here in Wisconsin, and I can get all sorts of insights to what's going on to help me with troubleshooting without needing to do a site survey. without needing to go travel, do a truck roll, hire somebody to go on site, use a local resource. I can get all this insights remotely.
We should have got together here for an on-site together episode,
Goodness,
Jerry. Here,
coming.
you're just down the street here.
That's right.
They're in the
Although,
Wisconsin.
with it snowing out here, I don't know if we want to leave the house. So the
Yeah,
50 mile per
true.
hour winds too. That's
It is a little brutal out
also a
there
strong
today.
deterrent. But
Yeah.
I'm sure Jerry remembers this, but back at Live, to your question, Al, from earlier, we had a fun episode where also, if you want to see UC2 from Hamina on the show, we grabbed I think it was a JPEG off the wall, if you will, or
Yes.
the internet, and designed a network in under a minute. And that's a video out also on our channel. And I think it's a 2-minute video out on the
Yeah.
channel. So you can check that one out as well. Just wanted to give a quick plug for that too,
I'll
Jerry. That was
I'll
fun. It was great to
I'll
see you
do it
guys out
even
there.
one better. I did this. I took a picture off the back of my hotel
On
room door the
Weston.
other day.
Oh, sure. Yeah.
Yeah.
The
Yep.
Heavenly
And this
Dead.
is a fire escape plan. Check this out. If I just pull this in, it understands it, whether, in the past and not that long ago, you needed to have some very complex floor plans, right? With layers and CAD
Yes.
files, all the,
Wow.
the,
Look at
the
that.
PDF of the layers. Now, even just a photo of a fire escape plan provides the same kind of results in the sense
Wow.
of it interprets that as a floor plan. It understands, okay, that object is an elevator, that object is a door, that object is a wall. So yeah, literally just with my iPhone, took a picture of the back of my hotel room door, drag and drop it into here, and you can see that quickly I'm ready to start, simulating RF and, placing access points and seeing how different objects and different placement of that access point is going to impact the signal propagation.
Yeah, look at that. It looks like it even got the elevators. Hey, there's
Yes,
Yeah.
materials, and yeah, that's
exactly.
pretty
Yeah, and you can see
impressive.
how
Yeah.
impactful those
Much
elevators are into
attenuation.
your
Yeah.
design. Yeah.
Yeah. And you know what? This is a great example because this happens. I've done this before. Me use the fire plan to be able to, because you don't always
Oh,
have good CAD drawings or something like that. So
No.
yep. Yep.
Yeah, you'd be surprised how many people don't have those drawings or
yeah.
those files.
Yep.
Agreed.
But if we go back to this one, so let's say we take our live data, right? And we identify, maybe let's just say everything's working fine at the site, but we want to simulate making some changes. Maybe it's from a refresh standpoint. Maybe we need to add some new technology, right? Maybe we're considering doing something like exploring using UWB and we want to do ultra wideband here for some location tracking, or maybe like a private cellular. The cool part is all of this information that we've learned about this site, we can now use to do all sorts of things. I like to call it the sandbox. So we can go from the live view to now the simulation, and now we're playing in the sandbox. And in the sandbox, we can do really whatever we want. We can get creative. I could take okay, our existing AP model right now, we've got some older 3802Is. Maybe we want to simulate swapping those out with something that has a UWB radio, right? Right now, if I look at our UWB coverage, you can see we don't have any UWB coverage because we don't have any technology that supports UWB in the space. But what if we want to just simulate, okay, we're just going to rip everything out and replace it with some new 9178s. And as soon as we put in 9178s, look at that. Now all of a sudden we have UWB coverage, and we actually have some pretty decent UWB coverage throughout this facility. If we just do a rip and replace, we can actually get some pretty good ultra wideband coverage. And now we have a whole new technology that we can use. One of the other things we can then visualize is the positioning accuracy. Most likely, if you're looking at utilizing something like ultra wideband, you're going to want to get down to that centimeter kind of level positioning accuracy for some type of tracking. And now we can actually see that. We can see here, based on the density of the access points that we have in this environment and kind of how open it is, we can see that we can get this kind of centimeter level accuracy in all the areas where it's green. And then if we want to visualize that even a little bit further, I could say, let's throw in like a UWB tag to actually simulate what does that look like from a triangulation standpoint, as far as, how many different anchors it's going to be able to hear, and what happens maybe when this device, whatever it is that we're tracking, moves into this area where we don't have as many APs that are audible in that area, we can start to see this kind of ghosting effect happening right with our tag to see how much kind of we're going to see in variance of that location and how we're going to see that kind of drift start to happen in these areas. So if we really need that location accuracy in this part of the building, now we can simulate maybe adding an additional 9178 into this area to kind of help improve that location accuracy all the way down into this like corner of the building here.
Nice.
But typically, if you haven't worked with UWB, what I've heard is you want to have at least minimum, very minimum 3 anchors audible in each of these areas, like line of sight audible, and then 4 is optimal. 4 or more is optimal for really good location accuracy. So yeah, something to keep in mind if you're going to start considering some of these kind of newer technologies and looking at wanting to simulate that. The cool part is we're playing in the sandbox. We can do whatever we want here. It's not costing us anything. We're not ordering equipment at this point. We're figuring out what it's going to take. We can very quickly create like a bill of materials and figure out exactly how many access points it's going to take. And even in addition to that, we could even input, where our switch locations are, and then we can start connecting everything up to our switches to figure out how much cabling and things like that we're going to need as well. So very quickly we can figure, okay, how do we want to connect all this stuff? If I do a connection to our switch, we can see this quickly, how much power we're going to need, how much cable we're going to need for this project. All that gets added up into that bill of materials as part of that process as well. So yeah, very, very quickly can run through multiple scenarios. The UWB is one, obviously consideration, but maybe you're considering, maybe we should use BLE technology for that location. Does that get us enough location accuracy? Do we get tertiary coverage? All those kind of details. But then, yeah, even things like Zigbee. What about private cellular? I know, Al, we've talked about private cellular before. Is that something that you guys are seeing?
Yeah. Yeah, we have an offering. Cisco's an offering. It's a hosted offering, where you own sort of the core part, and then we host all of the management of the network, or our partners do. So yeah,
Yeah.
and we see that as a really complementary technology to Wi-Fi, right?
Yes.
I think in the early days it was sort of like, hey, it's going to be one or the other. It's like, no, they're like completely separate use cases. So
Yeah, I'm curious what you guys are seeing on that. What I've been seeing and talking with people is, yeah, I totally agree. Like complementary, like it's usually actually a lot of times it's because the Wi-Fi is so heavily utilized. Where can we get some additional spectrum? And not just where can we get additional spectrum, where can we get like a QoS type Wi-Fi connectivity, something that we can kind of guarantee we're going to get a certain performance and reliability from that, where Wi-Fi being it is unlicensed, we've got to contend with all this other technology in that space. You don't always have full control over that, where something like private cellular, it's wireless, but it's not Wi-Fi. It's this kind of soft licensed frequency where you have more control over that. And you can kind of guarantee a certain quality of service there with that wireless connectivity. So thinking of something like a point of sale system, for example, you may want to offload your point of sale system from the Wi-Fi side to the private cellular while keeping all maybe your guest users, your laptops and things like that on the Wi-Fi side of things.
right. Yeah, exactly. We see this in the medical areas, uh, large public venue sort of things like that you were talking about. So yeah.
Yep. Yeah, and I think what's pretty cool is like when we add in like all the walls and doors and everything like that in here, you'll see like when I place a cellular radio in here, like look at the coverage of one cellular radio in comparison to something like we'll take like one Wi-Fi radio. I mean, you're talking like about, in this environment, about one cellular radio covers about the same as probably about 6 to 8 Wi-Fi radios. And obviously with Wi-Fi, we're designing for different things. We're designing for capacity, not so much coverage. But yeah, usually with cellular, because we're going to have a lot fewer clients on the cellular side, We tend to kind of design more for coverage than for
Right.
capacity on the cellular side. So yeah, you don't need, it's not like you're doubling up the number of devices in the environment to provide both private cellular and Wi-Fi. It might just take, a couple of private cellular radios depending on the space that you're covering. And now you get a whole additional chunk of spectrum that you can kind of dedicate for those certain critical devices.
And what I like about this is, somebody's looking at it saying, well, what would it take to do this, right? You can place these on the map in a matter of minutes, get an idea
Yes.
about what it would take, right?
Yep.
So,
Absolutely. Yeah, that's the beauty is like once you've set up this project, which as I've shown here, like you're talking very few clicks, very few minutes, if anything, to get this project set up. And once this project is set up, you can simulate all these different kind of technologies really quickly to figure out what is going to be the exact, right solution before you go through any costly expenses of running cable and hanging equipment and then realizing it's not the right solution or we need to add, now private cellular or something like that later on. You can figure all this up, all this out on the front end.
right. Yeah. Nice.
We had a couple questions on a couple things we've covered already
Mm.
here. How do you connect Hamina to Catalyst Center? Is that
Yeah,
process quick, or how do we talk about that a little bit?
it
And
is
then
pretty simple. Yeah, we can definitely talk about that. So it is
okay,
pretty simple. So if I just go to a new connection here, you can see this is essentially the information that we need to input into Hamina. So to get
okay,
Hamina to talk to Catalyst Center, it does talk directly to Catalyst Center over like an IP address of the Catalyst Center. We do
sure,
have some documentation about, ports and what IPs
sure,
that it's going to be you need to allow to talk to your Catalyst Center.
sure,
And then yeah, it's just a username and password to allow that communication and allow the API connection to happen between Hamina and Catalyst Center. On
nice,
the Meraki side, it's even more straightforward, being that Meraki is in the cloud. You're talking literally just a dashboard API key. So you generate that dashboard API key from your Meraki account, choose which region you're on, and you're good to go. So yeah, very, very straightforward. When it's cloud to cloud talking, it makes things very easy. When you've got to go cloud to something local, then there's probably some firewall rules and things like that that have to be implemented to allow those IPs to talk to your instance. But yeah, it's pretty straightforward to get that opened up.
Yeah.
okay, thanks. And then the last question here right now is around UWB. And on that subject is, does the frequency of the UWB tag matter in planning?
Ah, good question. Yeah, so if we come into here, we've got yeah, we can look at this from coverage or for positioning accuracy. Go back over to the simulation side, and then from there, if we go into like our channel side things, we can go under our ultra wideband to choose those different frequencies. So we do support this channel 5 as
Hmm,
well as channel 9 that you can simulate.
okay,
And let's actually see if we switch from channel 5, which is using about 6.5 gigahertz, to basically channel 9 being on almost 8 gigahertz. Let's actually see how that does change things. And you can see, yeah, going from 6.5 gigahertz up to 8 gigahertz does definitely make a pretty significant difference as far as coverage
wow,
goes,
yeah,
as well as for that positioning accuracy. So yeah, there is some consideration there about which frequency, which channels that you're going to be using, depending on the technology, depending on the tags, what they support, those kind of things. So yes, you can simulate those different supported frequencies.
Yeah. Nice thing is it's out of band. So it's not interfering with your Wi-Fi at all. But bad
Correct.
thing
Yeah,
is
good point.
propagation is a little bit high, loss is a little bit more. So
Yeah.
yeah.
and Al, just to be clear then, so the Cisco APs that include UWB, then they're covering all those bands or both those bands?
I'm only aware of the higher band. It's not,
Okay.
after seeing this, now I'm thinking I need to go back and look at the data again and see if
Yeah.
I've got the data sheet right. Go back and make sure that's the case. But I was
Yeah,
aware of
that's
Okay.
the higher band.
That's a good question. Yeah,
Yeah.
I suppose it probably depends on, yeah, both the vendor side and making sure that it supports, which frequencies it supports, and then also on the tag side of it, which
Yeah.
frequencies does the tag side support?
We'll
Yeah, great question. I learn
yeah.
something new every time here.
Oh, me too. Yeah. We'll find out and let the listeners know, and maybe we'll
Yeah.
open up the next show and let them know at the very beginning. So,
Well, we can put in the show notes too here on
or,
the
yeah,
on under the episode. Yep.
sounds good.
Yeah, what I've found with UWB though is it is very, because of this high frequency, you can see it is very much like line of sight, where if you do
Yes.
have a lot of walls and doors and things like that, yeah, it's not going to penetrate through that kind of stuff. You need to have a very
Yeah.
high density of access points with these anchors, and they all need to be, for the most part, line of sight with each other, because you can see as soon as that, especially 8 gigahertz signal
Yeah.
passes through one of
Sure.
these walls or objects, there's not much coming through the other side of that.
Where I see UWB is it's more targeted. In other words, I don't need centimeter accuracy walking down the hallway, right? But I may need centimeter accuracy if I'm trying to gauge something from a manufacturing standpoint. A use case is like if nurses or doctors going into the OR have to scrub for a certain amount of time, I can document that with that sort of level of accuracy, that sort of stuff. There are things like that can be documented that I need that precision for, right? But not everything do I need centimeter kind of precision.
Yeah.
Hmm.
And you can adjust that as well in the requirements here. So yeah, if you do have a specific level of accuracy, this is what these thresholds are defining as right now. Anything that's green is within 20 centimeters of accuracy, and then from 20 to 50 is yellow to orange, and then anything that's below that 50 is going to start to go into that red color. But yeah, if you don't need that level of accuracy, you can adjust these knobs. So if we were to increase this to like 200 and let's say 100, you can see kind of what that ends up looking like.
Hmm. That's cool.
Yeah.
Yeah. Yeah, this is a lot of fun to play with. I mean,
Yes.
because like you said, you have to. I feel like you have to be a little bit more precise with this. You're saying, hey, I want to get that level of coverage in this area or that level of accuracy in this area, and you have to be a little more precise with placing your APs. Wi-Fi maybe is a little bit more forgiving, right?
Yep.
You can move it to that side of the room or this side of the room and still cover the whole room, right? But ultra wideband, you got to be a lot more. You got to be conscious about where you want to have that higher levels of coverage, which
Yes.
is good, I think,
Yeah.
right? So
And I think to your point, Al, I like your it's fun to play with, because that's what
yeah,
I've been having a
yeah,
lot of fun
exactly.
playing around with UWB, because it is I'm not a UWB expert by any means. I think it's a very interesting technology. It's a very new technology, and coming from a Wi-Fi background, I think it is very interesting to see some of the similarities and some of the major differences when you start dealing with some of these higher frequency technologies and dealing with like location accuracy. But I think that's what's really powerful about a tool like this is that you can simulate and play around in the sandbox to figure out, hey, is this at all in the realm of possibility from a budgeting standpoint or anything like that? Very quickly, you can start to really understand that technology and visualize it. And to your point, let's just say we'll do a quick design of this office type environment here with some elevators and a lot of rooms, just to show you that point is, let's go and do a design. I will use the 9178s because I want that UWB radio. And
Mhm.
let's say, okay, we're going to design this for good Wi-Fi coverage. So right now, this is what it's kind of simulating for a good Wi-Fi deployment. So we have good Wi-Fi everywhere, good seamless roaming throughout this environment. What does that look like when we go and look at like UWB for something like positioning accuracy? And you can see, yeah, in a very walled environment with elevators and all that kind of stuff, you're not going to be able to just rip and replace your
Right.
Wi-Fi APs with 9178s and then get location-based accuracy, right? So you can see how bad that would be from a centimeter level kind of accuracy. Now, if we look at it from a Bluetooth standpoint, we look at something like tertiary coverage, we actually don't look too bad, right?
Right.
This is like what we've been kind of designing for as far as location stuff for a while now, and this might be good enough, right? Maybe you don't need UWB or
Just a few more access
maybe,
points,
yeah,
maybe. Yeah, and yeah,
Hmm.
but
yeah, just
not a big difference in the design, right?
depends on the use case. Yeah,
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 yeah. No, exactly. Yeah, it's fun to play with. It is. I
yes,
remember when you guys first released it as a beta feature. That was I went to it right away because it was a lot of fun to play with.
yeah. I could show you a couple other scenarios on the AI detection features and show you some of the latest and greatest there if there's interest on that, or I don't know if we have any other questions before I change gears here.
Yeah, that sounds good. I don't see any other questions right now.
Okay. Let's do this then. So I want to show you guys the some of the latest and greatest in the AI detection side of Hamina. So we showed like the walls and doors and objects, but some of the other things that we've added is like we'll do a data center. And if we choose data center here as the environment type, that's going to kind of tune that AI detection to look for specific things that are related to that. So now if I come into here and I say, okay, let's grab our data center floor plan here. Again, these are just floor plans, just Google search for data center floor plan. Nothing special about these. So really any floor plan, kind of works for this. These are not layered floor plans. They're not CAD files or nothing like that. But it's one of the first things you'll notice it did. If you're paying attention, you can see these little notifications here of all the stuff it's detecting. But the first thing in the bottom right corner there, I'll make the text a little bigger here too, but you can see it detected the scale automatically. So once it does that, now it has a good reference of kind of what it's looking at from an object standpoint, once it kind of knows the size and scale of this stuff. Now, if I go into like the 3D view, you can really get a grasp for what all it's picking up. So we can see it detected things like walls and doors like we already looked at, but one of the other things it detected was all the racking in here for like the server racks here, right? So obviously stuff you would commonly have in a data center. It's also appropriately, kind of size these to what a typical rack height would be for these kinds of environments. So it does a lot of kind of, it has a lot of intelligence in that sense of knowing, what the default height and attenuation and things like that are for these kind of objects. And really that quickly, like all I did was create the project, drag and drop the floor plan in or selected it from my list. And from there, if I want to just start placing access points, we can actually start to see how these access points are going to interact with this type of environment. And maybe even from there, if I don't want to manually place them, we could do like the auto plan. And again, choose your specific model AP that you want to plan for. And you just hit start the plan. And now it's going to go through and again, use some intelligence understanding these objects of where's going to be some good places to place these access points. And by default, it's going to use kind of industry best practices for looking at things like, okay, how do we make this network make sure there's going to be seamless roaming throughout the environment, as well as making sure that there's good redundancy, meaning that if any of these APs were to become go offline for whatever reason, or maybe become overloaded with too many users, making sure there's at least 2 or more access points in any of these areas to make sure we're going to have a good seamless experience for any type of users, whether they're stationary or roaming through the environment here.
How do you
And
typically use this? Do you is this a fire and forget kind of thing, or do you typically say, hey, this is a good starting point for me? Now I may need to add some, because it wouldn't necessarily. Let's say this was an area where you had a ticketing area or something like that, like you were talking
yes,
about earlier. It may not know that, right? And
yeah.
so you may want to augment. Is that how? I don't know. What do you think? Is it?
Yeah, no, I would totally agree. I usually use this as a good starting point or a good for very few clicks, very little effort. I now have a rough order of magnitude of how many access points is it going to take for this type of a project. But
Sure.
no, this is not like print this off and hand it to an installer and say, go install these APs in this location. There's still some, checks and balances that need to happen here. One, I haven't even figured out, how are we going to cable all this? How are we going to power all this, right? We need to factor in all those details still. But this at least gives me a very quick way to kind of get a good feel for, for budgeting purposes, is this in the realm of possibility before we go through and do a lot of engineering effort on this? But the cool part is once maybe we are good with this, or like to your point, maybe there's a critical area that it missed. Like let's say this is, I don't know, some really high density area. We're going to be having some event, this is the event space or something like that over here. So I want to factor that in as well. So I'm going to come in here and I'm going to define a capacity zone. And we're just going to say we have like, I don't know, like 150 iPhones, and we're going to have like 100 MacBooks, just to put some numbers in here. Now what I can do is just click and drag an area and say I just dropped 250 clients to all connect to the network in that area. And yeah, to that point, now that we've added that additional detail, this is not going to fly, right? We've got over 100 clients connecting on our 5 gigahertz radio here. We do have only 39 on our 6 gigahertz, so the 6 gigahertz clients will be happy and okay, but any clients that are going to require to be on 5 gigahertz are not going to have a great experience. So some things we could do is come in here and see, okay, maybe we have a better mode we could put this AP in. So since we've got a 9176, it does support a 556 mode. So that means instead of right now, it's actually switched off and suggesting we disable the 2.4 radio. We've got a whole nother radio in this AP that we could be utilizing to help with that load balancing. And just by flipping this into a 556, we can see now we've got some better distribution of these clients. You can see some of them moving around now. And maybe we want to do that with some of these other APs nearby that are going to support that. And we'll put this one also in a 556, this one also to get some of those 5 gigahertz clients. And now things are starting to look a lot better, but we're still, over 60 clients here. So let's go ahead and maybe add one more AP to this area. And I bet you, especially if we have one more AP and we kind of spread these out a little bit, looks like this is going to work nice right here. So you can see it's rebalancing all the channels for me automatically. It's looking at, okay, what's going to be the most optimal way to configure the channels, the channel width, all this kind of stuff. And notice here, yeah, it did pick 20 megahertz channels for 5 gigahertz, but it does say we can use actually 40 megahertz wide channels on 6 gigahertz. And it will automatically and dynamically, as I add more APs, you'll see eventually we'll get to a tipping point where it's recalculating the channels here. It's going to say we don't have enough spectrum on even 6 gigahertz to support 40 megahertz wide channels. And eventually it's going to drop down to using only 20 megahertz channels on 6 gigahertz as well. Let's see, once it finishes recalculating the channels here. There you go. So 6 gigahertz channels now are switched down to 20 megahertz. So that's all part of the auto channel assignment. So it's going to give you some suggestions on how you should optimally configure that deployment depending on how many APs and the environment and how separated they are.
We have a question also on multi-floor designs. So, probably in a data center design, that's probably, a single floor building, but office space or whatever, where we've got multi-floor, how do we handle that?
Absolutely. Yeah. So we've had multi-floor in the tool for a while. And one of the things that we can do is just stack those floors up. So I've got an 8-story building here, and we can stack the floors and we can see the signal propagation between the floors. I'll give you a little sneak preview of something that's actually going to be released very soon. Is we've had this 3D, obviously view per floor, but one of the things that's going to be getting released here is being able to show the building floors as well in this kind of, I was told recently, this is called a dollhouse view, apparently is the, I don't know, technical term. But yeah, this is your dollhouse view then. And one, obviously this looks cool. I think, visually it's eye candy kind of thing, but also I found this to be super useful. Think of like complex environments like a warehouse where you've got multiple levels within that warehouse. You've got mezzanines and things like that. It's really useful to be able to stack these up visually to make sure you've got things aligned correctly and stacked correctly and spaced correctly. So yeah, this is not just eye candy, I guess is the point there. It actually does have some really useful real world purpose.
That's cool. I like
really
that.
Wow.
I think they'll get used a lot.
Yep.
Yeah.
Interesting.
But yeah, if we wanted to see just signal propagation between the floors, for example, if I go up to like the top floor here, floor 8, we can actually see where these APs are on the floor below. So if I turn on my heat map here and I click on like this access point, I can actually see what kind of bleed through are we going to see from that AP that's installed on the ceiling on the floor below up to the floor above. So we can actually see what that ends up looking like.
Wow, that's nice.
Yeah.
Yep. But yeah, very easy to
Was
set
there a
up.
marker? Did you align the floors with a marker or something like that? Is that
Yeah, let me actually just show you here. So if we just do a quick multi-floor demo, can't type, but close enough. I'm going to pull in like a floor plan that has multiple floors here. So let's do something like this. Actually, yeah, here's a nice multi-floor. Let's do something like this. There you go. You got something like that. We'll just take like floors 6 and 7 here. And if I just bring those two in, and the cool part, yeah, again, I just select both those floors, it pulls both of them in. So it's brought both of those in here now. Okay, so yeah, this is actually the same building I was just showing you. So I'll just show you how you stack those up then. So again, walls automatically traced, scale automatically set. So right away, I can go right into our align the floors. And I can actually even say, okay, assign the floors to the building here. And it even has this like auto align feature here once it's finished kind of computing the different floors. We can even click that auto align. Otherwise, I can actually just drag them and align them manually here to stack them on top of each other. Usually I just look for like something like a stairwell or an elevator to kind of align those. But now that those are aligned with each other, we can define things like the ceiling height, the attenuation. And if I just take like, okay, so we're on floor 7 here, which is the top floor. So let's just place like one axis point in here. I'll put one on the ceiling. Let's take our 9178, put that on the ceiling. And now I'm going to drop down to the 6th floor. And notice immediately we see that single propagation. It also shows me a little icon saying this AP is on the ceiling on the floor above
there.
me as well.
Yep.
And did you scale each drawing separately, or does that scale when you
Auto.
scale everything at once?
All auto magic. So yeah, now I can verify it. So I could click the scale button here and I can say, I don't know, something looks off. I like to cheat a little bit here, and I actually like to just take a doorway, which I don't ever recommend scaling a map to the doorway, but verifying I think is an acceptable way to do this. And basically what I'm looking at is this about 3 feet?
Yeah.
If this is around 3 feet or 1 meter, then I know that the scale has been detected correctly. And these are, residential, so it's a little bit smaller than 3 feet. In more commercial settings, you'll probably see more standard kind of 3-foot doorway. If we take one maybe more on the hallway, you can see it's right on at 3 feet. And that's actually a good example too of why you don't ever want to scale to the doorway, because some people are like, doorways are about 3 feet. If we scale it to 3 feet and we use like one of these more interior like bathroom doors or something that's only 2.5 feet and we set that to 3 feet, that's a large error in our scale, right? That could really throw off like the number of APs and the AP locations and all that kind of stuff. So scale is very important. That's why we've implemented this auto scaling feature that scales it for you, because we've seen so many kind of user errors of people not scaling a map correctly. And, then they're, either over-engineered the design, put too many APs or too few of APs just because the scale was, off a significant amount.
Yeah. No, makes perfect. It's kind of a percentage thing, right? If you're measuring a large area, a small percent deviations,
Yep.
not that significant. If you're measuring a small area, that same percentage of deviation makes a big difference, right? So it's
Exactly.
Anders has a feature request here for you, Jerry. He wants to be able to export this to Doom or Counter-Strike, this building.
Knowing some of the folks that we have on our product team with like Joel and some of these guys that are into the gaming side of things, I could definitely see that
probably
happening.
back
Yeah,
in
if we
someplace.
could prioritize that one, that'd be
Yeah,
good.
don't. Although you suggest that, and then you'll see that'll be the focus for the next couple weeks or months, and a lot of other important features will get delayed.
Yeah.
I think we're coming up on time, but I wanted to show off one more thing that is pretty exciting. That I actually got a chance to do a survey. If we got a few minutes, is that okay?
Yeah, that's fine.
That sounds good.
Cool. So this guy right here, we actually just did a webinar on this recently, actually last week with Hamina on spectrum analysis. So this is the latest and greatest, you could say, in the world of spectrum analysis. This is a tri-band spectrum analyzer made by NetAlly. It's called the NXT 2000. And what's cool about this is, as you can see, it's just kind of a modular, essentially looks like a big Wi-Fi, USB Wi-Fi adapter. So it does just plug in USB, which means I can plug this right into like my laptop. I can plug it into something like an air check here and do like handheld spectrum analysis. And that's what it kind of came out for initially. But what we did was we talked to the guys over at NetAlly and we actually partnered with them and we added that functionality to our Nomad device. So this is the
Nice.
Wi-Fi measurement device that we use with our Hamina
Yeah.
on-site. And
Mhm.
what's cool about this is I actually just got a chance to go do a site survey yesterday at a customer site with the this integration. So we've supported now the NXT 2000 for a little while. What we've been working on, or what our developers have been working on, is the ability to do site surveys, which means like when you go do a survey, it's going to record the spectrum data as part of this. So I'll just show you, we'll work in reverse a little bit here, and I'll show you my NXT survey here. So I did a survey here and I tracked down a couple of interferers in the environment here that were broadcasting some signals. And if we want to look at kind of how devastating maybe some of these signals are, we now have this little survey explorer view here where I can take my survey path. So this is all the APs and everything that were picked up. But if I take my little surveyor and we put our surveyor in here, you can see now we're starting to see our survey data here. And if we come around and we look at some different paths of the survey, these are a couple different times. Yeah, here's one. So I picked this guy up and saw it on the survey path. If you look around channel 144, you see these really narrow spikes here, these
Yeah.
really tall, really powerful spikes.
Yeah.
That's that interferer. And you can see as I was kind of standing right in front of it here, it picking it up in the amplitude to kind of help me, locate where that was in the building. So I can either be kind of looking at some of this data as I'm walking around or just do my survey and then kind of look through the survey and then figure out, okay, where was I when we saw that, kind of peak as far as its power output to give me a good clue of where that's located. I also saw some stuff on like 2.4 in this part of the building. Let me switch over to the 2.4 side here. And yeah, we even saw like if you look around channel like 8 and 9, I was seeing some stuff here in this part of the building here, and you can
Hmm.
see some of those spikes here. So Wi-Fi is obviously operating in these kind of channels 1, 6, and 11. We can see we do have some other narrowband type technology that could be Bluetooth or
Hmm.
Zigbee, some spikes and stuff in there. But check this out. So yeah, this guy over here. And now, if I go and look at my little note there, we can actually see I did notate what this was. And this was a little 2.4 gigahertz, little spy camera operating in 2.4 gigahertz. So analog video camera, not Wi-Fi, but yeah, operating in that space. So that's all getting picked up on all the different bands. If we look at, even like 6 gigahertz, they did have 6 gigahertz deployed. However, there wasn't a lot of activity on 6 gigahertz. You can see all their APs on 6 gigahertz, but notice along the spectrum, other than a little bit of Wi-Fi traffic, really nothing going on 6 gigahertz throughout the building here. And if you want to, I'll even show you a little live demo just to show you how fast that is. Let me,
While you're pulling that up, I see an internal comment here on one of my chats. One of my team members said that now he's even interested in a dollhouse along with his 4-year-old, based on the Hamina feature here. That
that's awesome.
so update those gift lists, Christmas lists, or whatever
That's right. That's
accordingly.
right.
Export that to a 3D printer.
There you go. Exactly.
Well, let me go. Let's see. How does that come through
Yeah,
sharing the
yeah, we can see
phone?
it.
That comes okay.
Yeah.
Okay. So this
Yep.
is the
Looks
Hamina
good.
on-site application. I have the Nomad device here plugged in. I'll rotate this into the landscape mode here, so that way, hopefully, that maybe is a little easier for the viewers
Yeah,
to
it looks
see.
good.
That looks good. Okay, cool. So now if we go down to the spectrum part of this, and I'm just using an iPhone 15, you could use a larger display like an iPad or something as well, especially for like spectrum analysis that might be particularly useful. But the cool part is when you do your survey, it's going to record all this information and then we can play that back in the browser. So you could put it on a big, large, 30-inch display or whatever if you really want to dig dig in deep to the data. But if we want to analyze this live while we're on site, maybe trying to track down an interfere, this is one way you could do that. So let's do this. Since I don't have a whole lot going on in my environment, I do have some interferes. So I'm actually going to take this guy, and I won't show you what it is yet. I'm going to see if maybe somebody from the audience might be able to guess what this is. First, I'll see, can you guys pick up where this interfere is at on the spectrum? It's a really narrow interfere, to give you a clue.
Top right.
Do you see it? Any guesses of what that is? If we zoom in.
Some sort of a video transmitter?
It is not a video transmitter. I'll give you another clue. I'm going to kind of move my hand around near it, and you'll see it kind of dances, right?
Like a location.
Yes.
I'm trying to say
Motion
sensor. Yeah, there we go.
Exactly. Yeah, so this is using a radar technology. It operates in 5 gigahertz. So this is in the 5 gigahertz band, and it's in the upper 5 gigahertz. And this is actually a motion sensor that you would see in probably more commonly in like a warehouse type environment. The interesting thing when you think about that is where are motion sensors generally installed? Usually on the ceilings, right? And they're usually connected or associated with like light fixtures to like turn lights on and off, depending on if nobody's, occupancy. Really, occupancy sensor is what they're more used for, to say, hey, if nobody's in this area, turn the lights off, after so much time. But they're constantly emitting the signal to check for a presence of, a person or something moving in that area, and then turn the lights on. This doesn't look probably too detrimental in the sense of it's just impacting one channel on 5 gigahertz, very narrow. I can tell you, even with how narrow this is, if that's set right next to an access point, that channel 157 is going to be, knocked out, right? The AAP is not going to be able to talk on that. Even though it's very narrow, it doesn't, consume the whole 20 megahertz, but just by having that narrow spike, it's enough energy that it's going to trip that energy detect and prevent that access point from using that channel. And that said, is generally in like a large warehouse, you're going to have a lot of these sensors, right? Possibly in like every aisle of the warehouse or something like that. Well, each of them are going to kind of use a different channel in that upper part of the 5 gigahertz spectrum. So your whole upper 5 gigahertz might be completely knocked out if the environment is using this type of sensor, this type of technology, and has got a bunch of these all throughout the warehouse. So something to be aware of. And to be able to pick up, that even a very narrow interferer like that, you can pick up during the site survey.
Does it display like resolution, bandwidth, sweep times, that kind of stuff? I don't see that unless I'm just missing it.
Like on the data sheet you're saying, or like
No,
in
no, like on the
Hamina?
display, so
Oh, yeah, good question. We don't actually display the specific details about the RBW, like resolution bandwidth or like the sweep time. It is very fast. I know that's on the data sheet. I don't remember what it is off the top of my head, but check this out. If I do take this, and right now we're at a half a second time span. If I take this down to 0, we're actually going to show this in real time now, so you can really get a feel for how fast this is sweeping. So we're not holding any of this information. There's no hold time or anything here. It's just showing you as it's seeing any blips in that technology. If I go over to 6 gigahertz, same kind of thing. Now we're sweeping 1200 megahertz, but you can just see how quickly there's activity that's happening. Let me actually set the delay here, even
There's
0 on here.
There.
Yeah, so you can see the spectrum dancing there. And again, this is pretty boring environment. If we go to 2.4, there's always a lot more interesting things to look at on 2.4 with, I've got my Bluetooth headset in, I've got a Bluetooth mouse, all the different, kind of other technologies that we're going to see. And if we lower that down to 0 kind of hold timer, and this is even going across the screen mirroring. So I'm sure there's some, some slowing down and delaying, but it's very fast.
Yeah.
Wow.
Okay. You can't change sweep rates or anything like that, right?
No,
Okay.
you can't adjust it other than just the kind of hold timer on that. So that can help you if you're trying to locate like a frequency hopping device versus something that's a constant transmitter on a specific channel.
Right.
I'll take one more little, that same video transmitter that I showed you in the demo before. If you want to see what this guy looks like live, I'm going to turn this guy on. and you can see pretty quickly, where that is on the spectrum. So this is what a video transmitter would look like, right? One, it's going to be very wide in the sense of, yeah, video requires a lot of bandwidth, right? So it's generally not going to be that narrow transmitter like we were looking at before with the motion detection. So yeah, it depends on what technology it is that's in the space. If I change channels on here, you can see kind of how quickly it picks that up. And also notice even on like channel 1 here, yeah, I was figuring this might be loud enough that we can actually knock out that access point. So you could see that AP was, it was showing an AP on channel 1 before, but now with this transmitting, it's continuously transmitting enough that it can't hear that access point anymore. If this was next to the access point, it would actually keep the access point from transmitting at all as well. And likely that access point would end up moving to a different channel is what we would see happen if I put this right up next to the access point. But yeah, if I just move it back to a different channel, we can see that AP reappears on channel 1 there. And we can see the details here under like the access points here of those APs. But yeah, this is all the information that would get gathered as part of that site survey process that then could be played back as well.
Very nice. Yeah.
Yeah, someone
That's a
shared
great
in the
addition.
comments here that
Yeah.
they had worked with trying to find an interferer for a new building, a new install, where they determined that the interference source was motion and occupancy detection on the actual, built into the lights, and they had
Oh,
to end
right
up
into the light itself. Yeah.
contacting the electrician to go back and remove that
Wow.
after the fact. It's interesting.
Yes. Yeah, they can be pretty detrimental. I mean, especially yeah, if they're all over the place on every light fixture. Yeah, I
Yeah.
could see that doing some pretty big harm to a pretty big chunk of the spectrum.
Yeah, there is one last question too, and it's an interesting one I thought around. Is there any way to do scale or set scale diagonally? Like, let's say you shot a laser across the
Yeah.
building to the corner. Is there a way to do that where you're doing both X and Y scale simultaneously?
Um, Maybe I'm not understanding the question, but we can absolutely do the scale diagonally. So we only use one measurement as far as scale goes, but there's nothing
Okay.
that says we have to do left to right or top to
Okay.
bottom. I could
Okay.
absolutely do like corner to corner, and I
I
can
see.
set the scale that way. And I do
Okay.
that often because I want to use as long of a measurement as I can if I
Yes.
need to manually set the scale.
Yep.
So for like an outdoor thing or something that where it can't auto detect the scale, that would be a great way to do that. So yeah, absolutely, you can do diagonal for those measurements.
I think the
Okay. Thanks.
question was even so, sometimes images don't come scaled correctly, right? So, like X to Y ratios, like it's
It's
completely,
skewed.
yeah.
Sure.
So
But we
I
know
Yeah,
don't
the
think this is,
building
I've never seen
dimension.
this
Yeah.
available, but if you could actually separate the X and Y and scale them
gotcha.
separately, you could compensate for a drawing that's not
Hmm.
scaled X to Y correctly.
Yeah, that we would not support inside of Hamina. I would say, yeah, if I got something like that, I suppose I would probably try to kind of correct that before I brought it into Hamina.
Yeah.
But yeah, that's an interesting one. Yeah, if that's a common use case, we could definitely look at exploring adding something like that.
But yeah, they responded that they said thank you. The corner to corner is what they were looking for.
Oh,
So
cool.
that
Okay, perfect.
answers the question. Thank you.
Yep.
Cool.
Oh, this was kind of cool too with this survey. So I documented all of the photos. So that's another thing with the Hamina on-site is it does support um, the map notes, photo notes. So I just used the camera again on my iPhone as I was doing the site survey to document all of those AP locations. So in addition to kind of documenting the interference sources that I found throughout the building, I also documented where those access points were. So that way we have all that in a single place as well.
Nice.
And I'll show you one other thing that was kind of cool was we got to test out. This is a new building that they were deploying, and they've got some really thick walls in here. I'll show you like a photo of it here. This used to
Oh,
be like
wow.
a refrigerated storage. So we weren't sure, yeah, how that signal was going to kind of propagate through this space. So one of the things that we were able to do was I did a survey once we got the APs up, and we could actually see how that signal was going to propagate through some of these walls and objects. But what's really slick that Hamina does now is I can leverage that survey data into the simulation. We call it like surveys to design or surveys to attenuation. And without having to get in there and really calibrate the walls and objects of the specific dBs of each wall and property there or each door, we can actually leverage that survey data. So now you can see here under the simulation prediction mode, I've set it to learn environment of survey. And now you'll see it actually will take that survey data and now we can simulate different, models of APs, different configurations, different transmit power to see how that signal is going to propagate through that space. But it's leveraging all the data that it learned about the environment. It's learned the environment as part of the site survey process. So all I had to do is walk around, do that site survey like I would normally. And then it takes all that data into consideration of how that signal actually propagates through that space, through those objects.
So it automatically computed the loss through the wall then because that's
Exactly.
considered a year. Yeah. Okay.
Yep.
Cool.
Yep.
Very
The
nice.
So yeah,
comments,
normally in
by
the
the way,
past,
Jerry. Oh, sorry. Go ahead.
oh, I was just going to say, normally in the past, you'd have to go in here and manually tune those knobs. Now we can actually leverage that survey data.
That's nice.
Yeah, I just wanted to say that your Initech didn't slip by anyone watching here. That there's a lot of comments about Lumberg and TPS reports and
Love it. That's awesome. Yep.
all right.
Very
Anything
good. Yeah.
else?
I was just checking this question, see if there's
Yeah, there's a
we're at
lot.
the bottom of the
But
hour, so we
yeah,
probably
we got to
if
wrap,
there's anything
I
else,
think
we probably
here.
better wrap it up and
We'd
do
love to
another
have you back
episode.
though, Jerry, at some other point.
Absolutely.
This was super
Oh,
fun, super
fantastic.
informative here.
Yeah.
My
And
pleasure.
now we know that Site Survey Barbie's going to be lit this Christmas here
No,
on,
we and I think
under the
someone was
trees
asking for
here.
that Osseum as like an accessory for their Barbies. Isn't that what I
I
saw?
think so. Yeah, I
Yeah.
think so. Yeah. So
It's a whole new product. I mean, whole new line for Barbies now.
Right.
yeah, yeah. We're
The
not going to take
dollhouse.
credit for that, but we would like some royalties, Jerry,
Yep.
if
Get
Hamina
it on your
launches some of
Christmas
that.
list. Yep.
Exactly.
Start making your Christmas lists out.
Exactly. Exactly. Well,
Like
thanks
it.
so much again. Great episode. Love this. Lots of great content. I learned a lot here. And thanks so much for your time, Jerry, today. Thanks everyone for tuning in. And happy Thanksgiving for those who celebrate. And it looks like we're good on questions. Otherwise, if you know, or if you'd like to get a hold of us, you can always reach out. We have an email address, getunplugged@cisco.com. You can always send us a message on there. You can reach us via your Cisco account team, Twitter, X at Unplugged80211, or Threads at Unplugged Connectivity. Again, as a reminder, we do have our schedule for upcoming episodes. We are booked into the new year here. There's a lot of great content that's coming here in the future. You can find that schedule on our YouTube channel. It's the first link below the title header, I should say. And the YouTube channel again is on youtube.com/@getunplugged. So thanks, Jerry. Really appreciate you. Good job here today. Thanks, Al. Good to
Yeah,
see
great
you. Happy
information.
Thanksgiving, guys.
Thanks, guys. Happy Thanksgiving.
Yep. We'll see you. Till next time. Stay connected and unplugged.